The following is a presentation of the Six Arrows Radio Network.
Today on the Workbench, all about 3D printing. Stay tuned. Welcome to the Workbench. I'm your host, George, KJ6VU.
And I'm Jeremy, KF7IJZ.
The Workbench is sponsored by CADsoft, makers of Eagle PCB design tools. Get your free copy at cadsoft.io. And by MCM Electronics, where I can and you can buy all of your electronic parts needs and equipment. Check out mcmelectronics.com today.
Welcome to the Workbench podcast, where every other week we get together and dive into technical topics related to ham radio. This show is all about hands-on learning, and we talk about designing, building, and using ham radio gear. And along the way, we broaden our knowledge and we improve our skills. Whether you're an experienced ham radio operator or new to the hobby, if you like building stuff, this is the show for you. I want to take a minute before we start the show today to talk about our new sponsor, Elecraft. Kale mentioned that they're coming on board as a sponsor for both the Ham Radio 360 podcast and also the Workbench, and we're really excited to have them on board with us. The reason that we wanted to get Elecraft as a sponsor is that they're a very hands-on, build-it-yourself kind of company. From the very beginning, they offered great radio kits, and since then, they've offered not only kits, but also fully assembled radios, amplifiers, tuners, and all kinds of accessories. Personally, I've known Wayne and Eric since they started the company back in the late 90s. I was one of the first 100 beta testers for the K2 radio. And since then, I've added more Elecraft gear to my station, and I'm very, very happy with that gear. So it's really great for us to have them as a sponsor. But frankly, the thing that's most exciting to me is when we talked about them coming on board as a sponsor, we could see many opportunities to bring their expertise onto the show from time to time and talk about designing and building equipment. So you can really look forward to their expertise being part of the show content. We might even work on a build project together. So if you're looking for a radio with great performance or other station accessories, check out Elecraft. They have an outstanding reputation not only for top quality gear, but also for really great customer service. I'm sure you won't be disappointed. Also would like to get them in the Q&A section, so if you have any questions for Elecraft, shoot us an email at workbench@hamradio360.com. So to Eric, Wayne, and the rest of the Elecraft team, welcome to Ham Radio 360, and on with the show. Welcome to episode 13 of the Ham Radio 360 Workbench podcast. Good evening, Jeremy.
Good evening, George. How are you?
I'm doing fine, actually. Had a really good week this week. Pretty busy getting ready for the holidays and trying to clean off my workbench, although that wasn't very successful. How was your week?
My week was insanely busy, but last weekend was awesome because I finished the antenna analyzer build.
You did. So I saw a picture. I know you were assembling it, and I remember seeing a picture of a rogue piece of solder that got away. So how was the building experience?
Actually, the building experience was incredibly enjoyable. There was, I think the only mistake that I made, and I don't know why this went through my head, underneath the LCD, there is a 10 ohm resistor and a 10K ohm resistor near each other. And I put one of the 10K ohms in the 10 spot and had snipped it. I was so confident in my assembling that I had snipped the leads off and then realized the error of my ways and had to get the soldering wick, which I purchased after we talked about the build episode, and I was able to remove it. And there was just enough lead left that I could get through the holes and get it soldered back on.
So you got that all finished and working now?
Yep, it is completely functional. It really was a lot of fun. I mean, it took me, my effort was spread across a week because I have very little time, but on Sunday I had an hour or two to sit down and actually finish the job, and it was pretty awesome. There were a couple things for me that are going to be a little bit different than most of our listeners' experiences. First of all, with the LCD, I ordered, at least I thought I ordered the one that we had recommended, and the one I received from China actually had a little I2C backpack on it to make it easier for interfacing with Arduino boards. I took solder wick and tried. I could not get that thing desoldered. So I actually ended up running to the local micro center, and they had a blue and white 16 character 2-row module, exactly the same controller, same pins, everything. The only real difference is that it actually had pins or header pins already soldered to the LCD board, which was cool because they were literally the exact right length to go through our board and just leave a tiny bit sticking out. And, they were very quick to solder. So it was very nice to be able to run to a local place to get parts when I screwed up. A couple of other things is when I built it, I took your advice about cranking the heat up. Traditionally, I'd always been kind of given the guidance that you want to run the iron around, I think it's 350C for leaded solder. But I cranked it up to 400C, and man, did it, touch a nice chisel tip to the connection spot, and solder would flow on in 2-3 seconds. And that made a huge difference.
Yeah, it really does. I don't really understand why the general recommendation is a little bit lower. I guess it's so you don't fry the board, but if you get in there and you're fairly quick, on the soldering, then it goes quickly. The solder flows well. So yeah, glad you had a good experience with that.
Now, and to the point about the heat flowing quickly is when I was probably the most difficult thing to solder on were the rows of header pins for the Arduino, and that header actually got enough heat that it kind of deformed a little bit. Like the pins would actually kind of fall through the plastic, and those didn't get quite soldered on perfectly, which you can fix when you've only soldered one or two of the pins, but when you don't realize it till you've got them all on there, that becomes difficult. So out came the pliers and a little bit of mechanical bending, and I was able to get it so that the Arduino would slip on with no problem. Couple of other things. Yeah, don't laugh. Look,
it happens to all of us.
It does. A couple of things is when I first got to the electrolytic capacitors, which are the capacitors that look like little cans, I had a little bit of a heart attack moment because in our last episode we failed to mention that the electrolytic capacitors actually have a polarity. There is a correct way to install them, and on the board my eyes weren't doing very good at seeing the plus sign, but I was able to go into either the Eagle file or the PDF assembly manual and zoom in on those pads and see which pin was the positive pin, which is where the longer lead on the capacitor goes through. Plus on the side of the electrolytic, there is like a white bar, vertical bar, and that indicates the negative lead. So that helped. Also, we failed to mention using fume extraction if possible to keep that stuff from getting in your lungs. So I was able to do that. And probably the most important thing, and for those of you who follow me on Twitter and on the Facebook group, you may have seen a picture of my magnifying lamp with a big blob of solder on the side of it.
Yeah, that was what I was referring to earlier.
So, yeah, that was unexpected. That literally happened as I was dragging. I had a little bit too much solder. I was making a joint, and I'd put it in the little scrubby thing, and then was dragging it on the wet sponge to just clean it up. And that little ball of solder literally jumped, I don't know, at least a foot from the solder pad up onto my lamp. And so wear eye protection because solder is screwy.
Hey, by the way, going back to the capacitor thing, I was going to mention that on the Rev 6 boards, the first batch of 100 that we made, that little silk screen of the capacitor footprint is so tiny and it's so hard. There's actually a plus sign on that symbol, but you can't hardly see it. And I didn't realize that until after we made the boards. So on the Rev 7 boards, I put an extra plus sign where the positive lead of the electrolytic cap is supposed to go, and put that next to the capacitor. So that is really kind of a pain. The first time you look at it, you can't hardly see the original indicator on there. So everybody really needs to pay attention to make sure they get those in the right way.
Yeah, and that's like I said, that's why at least I was able to go into the assembly guide and zoom in the PDF, and I could tell quite easily then which one was the positive pad. One thing I ran into that neither one of us were expecting was with the installation of the Arduino IDE, which is the software that you use to program and to load Barrick's initial firmware onto the Arduino. In our instructions, we talk about going into the board selection, and the SparkFun Arduino Pro Micro 5V doesn't automatically show up. And, we tell you to search for SparkFun and that you should see the library and be able to load it. Well, I installed the most recent version of the Windows IDE, and it wasn't in there. So I had to do a little bit of Googling, and that ended up taking me to the SparkFun GitHub page. And there are instructions on how to get their libraries loaded into the IDE. So if this will be in the show notes, but if you are missing the SparkFun Pro Micro 5V, just go to github.com/SparkFun, all one word, /Arduino_boards. And follow the instructions there about loading those in. And that'll help you get the actual board interfaces in there. And then it will also give you an option in the Arduino IDE because you can select either the 8 megahertz 3.3 volt version or the 16 megahertz 5 volt version, which is the one we're using. And you can select that in there as well.
So once you did that, were you able to download the firmware pretty easily, or did you run into any issues?
I don't know. I did run into one issue, but then it wasn't an issue. The very first time you load the code in the top left-hand corner of the IDE, which stands for Integrated Development Environment. Sorry, my use of acronyms. There's a check mark you check that's supposed to verify your code prior to uploading it. And the very first time that I did it, I got 4 or 5 errors. And then I couldn't really see the errors. Like I went to the lines it pointed out and I just clicked it again and everything was fine. So don't know what that was.
Yeah, I don't know.
But everything's fine. I got the firmware uploaded. The closest antenna, I should have had a dummy load nearby, but there was literally, I have a quarter wave, like 2 meter 440 antenna mag mount up on the top shelf of my Workbench. And I reached up and I grabbed the BNC connector because it has a BNC connector, because I had been using it for a scanner antenna recently, and I plugged it in there and ran it. And as somebody on Facebook said, what do you have that plugged into that the best SWR is, 9.38 to 1 at 22 megahertz. So it did work.
Excellent. Yeah. That's great. I'm glad to hear it's working okay. I saw several guys on the Facebook page built them and loaded firmware, and they were up and running. So it's good to see that that other people were able to get it all up and running, and that's great. I think we're going to start to see a bunch of suggestions for improvements in the firmware. So we were talking a little bit earlier about maybe making some changes to it and making the button functions a bit more responsive and not having to wait for certain tasks to finish. If you look at the code, you can see what it's doing, and you can see why it's ignoring the buttons or when it's checking for buttons and all that, and modify it if you feel like it. And I'm sure that we'll get some people who make some changes, and we'll post that code as it comes around.
Yeah, and that's actually that's probably really the only annoyance with everything, because the sense of accomplishment I got by building this thing, I haven't been this excited about something in a long time, as far as like a totally high five myself. Oh my gosh, look what I just did. In fact, it was such a high that I went back to our Christmas shopping list episode and started looking at kits, because I just had a ball building this.
Bit by the building bug.
Yeah.
Isn't it great? Hey, by the way, I want to make a comment about this in general, and that is that when we were looking at doing this as a project, we didn't really dumb anything down. So for you guys listening, and pat yourselves on the back, because the board design was not all spread out with gigantic components. It was the density of a through-hole board that you would find in a commercial application. The pads were not overly large. The components were pretty crammed together to fit everything in a compact space. The fact that you had to solder the parts together, install the IDE, modify to make it work, compile, and then load the firmware. I mean, you went through a lot of steps and learned a lot of stuff to get to the point where that was running. So it wasn't unnecessarily difficult, but there's a lot there. And so for a lot of listeners, for those of you who went through this for the first time, that's really awesome, and I'm really proud of you guys.
Well, it kind of goes back to a comment you made in the last episode, which was, as you're putting this thing together, I'll be honest with you. I mean, when I was putting the, just the resistors in or the diodes in, it may not be intuitive. It's like, well, what are these parts doing and interact with one another? But one of the modules, you talked about learning these things as building blocks, and of course, using the little Murata micro switching supply definitely is a very self-contained little building block. Understanding now that LCD and that LCD driver are just bone simple to use, and can be used for a lot of projects. I mean, that's a building block. Understanding the Arduino IDE is a building block. Understanding how to read the board layout is a build. I mean, there really are a lot of really fundamental skills that this is way better than the Arduino Blink example.
Yeah, I totally agree. It's a more sophisticated project, the kind of thing you might want to do as a next project or of the same scope, but you'll become really more familiar with all these bits and pieces, and it'll be very second nature to you. It won't be a big mystery. And a lot of what I think we're shooting for here on the show is to motivate people to want to build stuff and learn about how it works and become comfortable with it. And these are just more tools in the toolbox for doing your own designs or just building someone else's kits.
Exactly.
So and also, by the way, since software is such a incredibly important component of everything these days, having that first level of familiarity with at least the concepts of, I have this editor, compiler, I need to take my source code and convert it to machine code, and then it gets downloaded and all that. When you do it a bunch, it's pretty simple. But if you've never done it, it's kind of, you don't know what you're doing. So it's a great exercise in going through many of these key pieces. And, if you look at industry, people that are making industrial control products, they may be more high fidelity, accurate, fancy, faster, whatever. But the fundamentals are the same. This is exactly the same as any commercial product would be in its fundamental components. So, maybe a fancy antenna analyzer would have a lot more features or have a higher frequency range or whatever. But at root, it's the same basic idea.
Now, to that point, obviously, a lot of you, our listeners, have definitely seen a lot of value in this kit because we sold out of the first run of 100 boards in 19 hours. We sold out of the pre-orders for the second run of boards in about 26 hours. And as of today, I think there's only a small handful of boards from the third run still available. In fact, actually, by the time this posts, they may not be. But definitely check over at hamradio360.com for information. And I have a feeling we're going to do a fourth and maybe a fifth run. And for those of you who are just sick of waiting because you haven't been able to get on those runs, we will... we are intending, there we go. We're intending to actually have these boards available for sale at Dayton.
Yeah, maybe that'll be board run number 10.
Who knows?
When we get there.
But I just want to say thank you very much for the support you guys have given us by purchasing these boards and going out and buying the kits. I mean, it's actually, for a hobby where a lot of people have been, started to be called appliance operators, and I'll put myself in that category. A lot of you see there's value in that it just feels good to build something. And the cool thing is you're building something that is useful. The only piece that's missing at this point is a way to make it portable and to take it out in the field. But I have an update on that, George.
A battery?
Well, actually, I forgot about the battery. Okay, a battery too. But no, I'm talking about a case.
What case?
Well, we actually, it's been a couple months ago, but there was a gentleman named Chris Weir, KM4 KTC, who reached out to me on Twitter a while ago after I had posted something about 3D printing. And I found out, first of all, he's a ham. He was a listener of the show, and he is one of the co-founders and CEO of a company we've mentioned before called Rocket City 3D. They're down in Huntsville, Alabama, and they run a 3D printing business that will do design, printing, rapid prototyping type work for everybody from small startups all the way up to, they've done some work for NASA down at the Marshall Space Flight Center. Yes, I think it's the Marshall Place. Yes, the Space Flight Center. But anyway, he had been very interested in this project and had gotten a board and put it together. And he posted on Twitter this week a picture of a prototype of a case that he had designed and printed.
Oh, awesome. I haven't seen that.
Yes, he had done a test fitting. He had sent me a note to say that he just had a couple of minor adjustments to make as far as getting the button one up. And my guess is, this is going to be round one. Because one of the things also, we designed this thing. It actually has a 2.1 millimeter power jack on it. So the initial version of this board, you will apply external power to. But the cool thing is he's going to do two things. Number one, he is going to make this board available for sale. This case available for sale to our listeners or anybody who's interested in picking one up for the project. But he is also going to make the design files available, or at least the printable, the STLs, which actually we'll talk about here in a minute, available for people to download if you have the ability to 3D print yourself.
That's awesome.
It is. And the cool thing about it is if you print it in a durable material, you basically have a thing you can now throw in your QRP bag and, head off onto the trail or take it out to field day, and it will be protected.
So if I wanted to get one of those cases, are they going to inventory them so you can buy one, or?
That I don't know, because I think most of their stuff is on-demand printing. Now, granted, they actually they do work for Gigaparts. Gigaparts sells. They were the first U.S. distributor of the DV Mega digital radio hotspot boards that we've talked about in the past, and they designed and manufactured a case for the Raspberry Pi with the DV Mega board on it, and they make those and send them to Gigaparts. I don't know if he intends on keeping a stock of these or if they will be made to order, and of course, there's no information on pricing yet. But stay tuned. We will bring you that news when we have it.
That is very cool. We should do a show on 3D printing.
We should. How about now?
Works for me. So
before we do that, George, what's on your workbench this week?
All this antenna analyzer stuff. Yeah, it's reloading the queue at the board fab to make more antenna analyzer boards. I haven't had a chance to work on anything except that, and I've got some repeater projects that I need to work on. We need to swap out some of the radios at our repeater sites, and so I'm getting some of that stuff wired up. But that's about it. Anything else on yours?
No, it's just been this antenna analyzer project. Although I will say this. The other thing that's on my, like I said last time, the thing that's on my workbench now is nothing other than the completed board. I actually was very proud of myself because when I finished, first of all, there were 4,000 little parts bags from DigiKey, which, to be honest with you, that was a pro tip. I haven't ordered from DigiKey in a long time, but I now have a collection of parts bags. Like, I kept every one of those because I know they'll come in handy. And even the static sensitive bags for those components are resealable with a little zip thing. That's amazing.
Yeah, I got a tip for you.
Yeah.
In the spirit of coming up with your little list of favorite circuits and whatnot, the components that were used on the antenna analyzer, you should make a list. Well, there's a BOM, right? We published the bill of materials for the antenna analyzer with all the DigiKey part numbers. And if you go back and say, oh yeah, I want to build some other different thing, and I want to use that same connector, that BNC connector that was on the antenna analyzer. If you just go to DigiKey and type BNC connector, there's probably like 8,000 BNC connectors that'll come up. But if you want that same one, because you know that the Eagle footprint is already done for it, then just order that same DigiKey part number. So keeping your own favorite list of components, your go-to list of parts, is very handy.
Plus your bags.
And, the reason I thought of that is that on every one of those bags is a sticker that has the part number.
Has the part number.
But I think we also put all the DigiKey part numbers in the BOM on the website.
That sounds right. And I will tell you this, because there were a couple bags I tried to take the stickers off. It doesn't really, they don't come off without ripping. So I stopped trying.
So for you listeners, if you want to get a hold of the files we're talking about, go to www.360workbench.com. That's 3 digits, 360workbench.com. And that's where we post all the build files.
So before I talk about MCM, I will tell people, because you posted this online. I didn't know if we were talking about it yet. we've gotten some feedback on folks about what the next project is going to be. And in talking behind the scenes here, George and I have kind of landed the next project is going to be a DC power related project. And that could be anything from a little like QRP solar charge controller power monitor type thing to something that is a power monitor that you could use in your shack. But we are definitely starting work on project number 2, and we will keep you informed about that as things come up.
And along the way, if you guys are interested in building a certain kind of thing, we would love to hear from you. So shoot us an email. Send an email to workbench@hamradio360.com and make some suggestions. We've already gotten some very good suggestions so far, and more feedback is really appreciated. So send on your thinking.
So, what's really sad?
What's that?
For those of you who follow me on Twitter, and hopefully you follow our sponsor, MCM Electronics, they have had absolutely crazy deals going on for the last 12 days.
The big discounts.
Yeah. And the thing that's sad is that this episode is posting on Tuesday. I don't remember what day of the week. Well, so today's the 16th.
It'll be the 20th.
It'll be the 20th. And all of those deals ended today. Or end today. And I'm talking like 25% off pretty much all of the stuff made by Tenman, including meters and power supplies. All 20% off all the Dura Tools brand tools, which was everything from tweezers to magnifiers to exotic screwdriver sets. And
You're just making everybody feel bad now because the discount thing is over.
No, it's over. I mean, hopefully you had a chance to take advantage of it. And that was only 2 of the 12-day categories they had. They had some of the other interesting ones where they had like little maker DIY kits available for really inexpensive. They had some really big sales on their quote unquote like the plastic weatherproof cases, several of which I own to store radios in. And if you haven't, by the time you're listening to this, if you didn't take advantage of it, it's over. But there's good news.
It's back?
No. You can't save necessarily the big percentages, but if you still place an order at mcmelectronics.com and use the code RAD10, you will save 10% off your order for almost anything in their catalog. There are some exclusions, but it is still a good way to save some coin on test equipment, power supplies, meters, tooling, parts, components. One thing that was interesting that they stocked that I was looking at the other day is I have a Raspberry Pi Pi Noir camera. They actually have a board that is a series of infrared illuminator LEDs in a circle that the camera will actually mount to. Like, that's cool. A brilliant idea.
Yeah.
But anyway,
you can see things in the dark.
You can, but it's just cool that they have something that's such a specialized piece like that. But
that's pretty cool.
Save 10%. If you missed out on the deals with code RAD10 at checkout at mcmelectronics.com.
So we will come back in a few minutes and dive into 3D printing right after this.
The Workbench is sponsored by our friends at CADSoft. They're the makers of the Eagle PCB design software, the very software George used to design the Pactena Classic, Pactena Mini, what him and Barrick are using to create this new antenna analyzer project for you here on the Workbench. They got hundreds of parts libraries, tons of reference designs, and a monster huge user community. Eagle's a great choice for your next ham radio project, and you can get your free copy of their software today. Click on over to cadsoft.io and start getting your project put together today.
So today we're going to talk about 3D printing and try to understand a little bit more about the technology and why you would want one. And Jeremy, 3D printing has been a really hot topic in general over the last several years. And I've seen more and more printers at stores and people doing all kinds of projects. So there's probably lots of ways we can apply it to our ham radio hobby. So why don't we start with the real basics? So give us an overview of really what is 3D printing?
So 3D printing at its very core is taking some type of a computer-generated model and then actually creating a physical object. Basically, for the types of stuff we're going to talk about, for all intents and purposes, it's desktop manufacturing. At the end of the day, and in simplest form, the machine itself is some type of computer-driven motion control system with some type of technology to actually create something. This classification of manufacturing is called additive manufacturing, because you are building things by adding material to your overall model, versus something like CNC or laser cutting, which is subtractive manufacturing, where you're actually starting with a piece of raw stock and you are cutting things away to build the thing that you want.
Okay, well, that makes sense. So when you talk about additive, what exactly is it that's being added? What's the stuff?
So there are two classes of 3D printers that are going to be most common that somebody is going to look at for home and not necessarily in a commercial or industrial usage. The first category, and I'm only going to just touch on this because we're not going to deep dive into it, is stereolithography or digital light projection, where light is actually used either from lasers or an actual, when I say a digital light projector, I mean even like a home theater projector, exposes photopolymers, that is a resin, and that exposure actually hardens it, and then a build plate moves through the vat and out comes a solid object. So that's
you mean stuff is like etched away from what's exposed or not exposed?
No, literally, it's a liquid resin, and as that top layer of resin is exposed, it hardens, and then there's a build plate that moves through the resin that pulls the solid down, and you're always exposing the top of that liquid.
Oh, wow.
Yeah, no, it's pretty cool, but that's quite expensive. What we're going to focus on is the category of printers that are known as fused deposition modeling or fused filament fabrication. And these printers basically take a spool of some type of plastic, run it through a heated extrusion process, deposit it on a build area, and then it continuously just makes layers and layers and layers and layers of plastic that stick to one another. And voila, after a certain amount of time, you have a model.
So if you want to put it in really simple terms, to me, it sounds like you take a hot glue gun and you squirt out some melted glue. And if you could do that in a super precise way, you could build something.
Yes. And the only difference being is that you're using plastics instead of glue. But yeah, I mean, that's pretty much it. You're squirting stuff out and that stuff sticks to itself.
Okay. So, you had some experience using a 3D printer early on. I mean, you've been messing with this stuff for some time. Well, how did you first start using 3D printing?
Well, actually, I haven't been doing, I've only been doing 3D printing for just a little bit over a year, but oddly enough, my first exposure to 3D printing was ham radio related. And this was the first time that I had seen a practical application for it and had seen something in person. And there was a community that Cale and I were members of. The Elecraft KX3 was a very popular radio, and one of the things that the radio had was this procedure to make it more impervious to heat changes. And part of this involved using a stable signal source to feed the radio and getting alignment numbers and whatnot. And Elecraft sells this little XG50 module, which is like a 50 megahertz, precise signal source, but it's a board. And there was somebody on the forum that purchased this thing. And, he started sending it out to other people that own KX3s, and, you would borrow it and then send it on to the next person. And somewhere along that chain, there was somebody who had a 3D printer, and he actually designed a little green case to put this thing in so you weren't just handling the raw circuit board, which was really cool. And that was really the first time that I had seen kind of like a practical, in my mind, granted, maybe I lack imagination, but other than just printing out trinkets and toys, this was one of the first times I was like, wow, that's really cool. I had a problem. I sat down at a computer and some amount of time passed and I have solved that problem.
So somebody just bashed out this case. Was it so? So this board has to go inside of a box, and the box has got 6 sides. Is the box created like one horizontal slice at a time, and then you grow the sides to make like a 5-sided box that the board went in? What did it look like?
So in this, truthfully, I don't remember if he had like a sliding top or if there were screws that held the top half of the shell and the bottom half of the shell together. But both of those are options. For instance, well, actually, to answer your first question about how it's assembled, so there is a flat plate that is, parallel to your table surface, and there is a print head that moves around, and it prints one layer at a time. And that is, and as the print goes on, those layers are the z-axis, and it just continues to add to the z-axis. And either the bed moves and the thing goes down, or the head moves and that goes up, and voila, an object comes out one layer at a time vertically.
So if you imagine, let's say you're doing a project and the box is like 2 by 2 square and an inch tall, and the bottom of the box is just a solid plate. So the head or the piece itself has to move back and forth. You're kind of like drawing raster scans of the molten plastic, and it solidifies, I guess, right when it extrudes, I guess, right?
Yeah, yes, and that is about its. I mean, effectively, yeah. At its simplest terms, that's correct. Is that it's moving back and forth. It is, because these things are very precise. It's putting these filament paths right next to one another. They touch and they fuse together. And where the surface is supposed to be, it's flat. And if there are walls that extend, up, it'll print the edges of that. And then there's something called infill. So you could print a solid object completely solid, which would waste a lot of filament. Or you can use infill, where you're saying, well, I want the outside skin to be completely solid, and you can set how thick that is. And then the infill is, you say, well, I want to fill 20% of the volume with filament, and then it prints a geometric pattern to give it some strength. But yeah.
So how thick is one layer of the print?
That completely depends. So for filament-based printers, the most common. Well, sorry, you said the thickness of the layer, correct?
Right. I'm just thinking, let's say if I want to make a box that's an inch tall, is that like 10 layers or like 100 layers of stuff?
So it's a lot more than that. And actually, layer height is a function of two things. Layer height is a function, number one, of your nozzle size. One of the most common sizes of nozzle, and when we're talking about nozzle, you're talking about the hole that plastic is extruded through, is 0.4 millimeters. And basically the rule is that a layer height cannot exceed the diameter of the nozzle. And truthfully, I don't even know that you would be very successful trying to print at 0.4 millimeters with a 0.4 millimeter. So for instance, the printer that I have now, I run a stock 0.4 millimeter, and I can print at anywhere between 0.05 millimeter layer heights to 0.3 millimeter layer heights. And the thicker the layer, in other words, 0.3 will print a lot faster than 0.05. Does that make sense?
Sure. I mean, it's just like 6 times more stuff. So
yes,
right. So that does make sense. But I would imagine also that those finer, the finer thickness of the layer also means that maybe the vertical surface would be more smoother, right? You wouldn't have as many obvious lines.
Yes, that is true. That the thinner the layer height, the finer the detail of the print is overall.
So some of the early 3D printers I saw, a sample object, you could definitely tell every horizontal layer to it, but maybe those were the more crude earlier printers. So if you print something, let's say on the kind of printer you might have at home, would you actually tell, looking at it from the side, that it's a bunch of layers, or is it kind of smoothed over?
Again, that depends on several things, between how expensive is your printer, or how good is it, how precise is it, to how much work have you done to dial your printer in to counteract any undesirable characteristics, to the material that you're using, to the speed you're printing. And when I say speed you're printing, layer height is one factor, but you can also tell the printer how fast to actually move the print head or the print bed around. So for instance, on my printer, I get pretty good quality prints if I print at, say, 0.2 millimeters, which is the most common height that I do. And I tell the printer to not move anything faster than 30 millimeters per second. When you go up in money in printers and you're getting into the like $2,000-$3,000 machines, they're able to provide really high quality and be able to print at 60 or 80 or 100 or 150 millimeters per second, which again just translates into your print getting done faster. But at the end of the day, no matter what, it's not possible to really get the layer lines to disappear. The key is to get the layer lines, especially in the Z-axis, to all be lined up with one another correctly. So even though you see those lines, if they're all even and correctly attached, it doesn't matter as much.
So I'll give you one example that I saw that really surprised me that it was 3D printed. So the Elecraft KX2 paddle that screws on the side of the radio, there's a plastic housing that the paddles sit in. And the plastic housing is kind of a clear, kind of cloudy, clear plastic. And that housing is 3D printed. And I was really surprised because it looked like molded plastic to me. And that's very smooth. I mean, you'd have no idea that it was 3D printed. So that must have been a pretty high-end machine that did that.
It could be, but there also, depending on the material, there are some techniques you can use to surface finish. So for instance, if you're using ABS plastic, ABS plastic is probably the first mainstream material that was available. It's not the best because it's a little bit finicky and temperature sensitive, and it will shrink as it cools. And those are things that, depending on the printer that you buy and the techniques you use, you can help overcome. But one thing that's cool about ABS is if I want a print to be perfectly smooth, you can take a little bit of acetone, pour it into a cook pot, and then put your print on top of some object so that it's not in the liquid, heat it up a little bit to create some vapor, and that will actually vapor polish the surface of ABS and make it smooth. So there are techniques to getting things smooth like that. Also, depending on the material, when we print to things, it gets printed on a build surface. That build surface generally is heated, depending on the materials you're doing. And so, for instance, when I am printing PLA, which is at this point the most common 3D printer material, PLA is polylactic acid. It is a plastic made from basically corn. At the end of the day, I mean, it's biodegradable, etc. But if I leave it on a heated build plate, heated at 60 degrees Celsius, generally speaking, those layers will actually kind of flow together and give you an almost perfectly solid surface on the bottom. And that's one of the things that when you have an object you want to print, you pay attention to the orientation of it, so you can take advantage of features like that. Oh, unfortunately, I haven't seen the KX3 paddle, so if you look up, have you tried to look at it with a loop? Do you see layer lines?
I haven't looked at that closely. I mean, after they mentioned that it was 3D printed, I did kind of take a look at it and thought, yeah, I guess I could imagine that this was, but it never occurred to me that it was 3D printed when I first saw it.
And especially some of the higher end printers that can reliably print at 0.05 millimeters, it is entirely possible that you wouldn't notice it unless you were looking for it.
Yeah, and that's probably the sort of printer they were using. I think they used an outside service to do it, so probably something like that. So that's kind of a good general overview. So from a ham point of view, why would we care? Obvious applications would be to make a case for a project, I guess. What sort of things would you think about using it for?
So, for me, it wasn't ham specifically. Obviously we're a ham radio show. Part of my desire in bringing this was to, just to introduce this as another tool in the toolbox. But as you mentioned, building project cases is one of the most common use cases. If I need to build an enclosure, for things, I'm also aware of other hams having used this technology to print, parts. If sometimes there may be some part to a radio or some part to an antenna setup or something where there's a physical part that you can't necessarily go out and buy, or where you could sit down and design it at a computer, use the right materials, and print something that would hold two things together. An example of that is if you look at an antenna like the Buddy Pole, where you have the little screw terminals that screw down on the little mini hooks on the coils. If you lost all those, in theory, you could sit down and design and print out replacements for those little screw pieces. But yeah, at the end of the day, the technology is important. And I'll say this, it is the most exciting technology that I have touched in forever. I mean, when I first got my printer and I got it tuned and I got it running right, and the first time I sat down at a computer with a real problem I had to solve, which at that time it was building a series of standoffs for Raspberry Pi Zeros as I was trying to build a Raspberry Pi Zero cluster. I had an idea. I sat down. I designed it in a CAD program. I was able to print prototypes and, continue printing prototypes, test fitting stuff, taking measurements. And I was able to get this loop and very quickly develop something that I was never going to be able to buy. I was never going to be able to really at that time, pay a professional company to do the work necessarily. And even if I was working with a 3D printer company like Rocket City 3D, the feedback loop of them printing a prototype, sending it to me test fitting, taking measurements, sending them feedback is a long, feedback loop. But here I was able to sit down in an evening and after a couple of hours design exactly what I needed for my project. And that is powerful.
So if you're up on the International Space Station and you snap a bolt, you could 3D print a replacement. Actually, I heard about that. That's a rather exotic application of a 3D printing. But if you're at a place where you can't just run out to the local store and buy an L bracket, just make one. And at first I thought, well, that seems like a little ridiculous. But the more I thought about it, actually, that's not a bad idea.
Well, and the one thing I'll say about that, though, is when you get into the wide plethora of materials that are available, you have to understand the materials you're printing with. So, if the first time that I became aware of 3D printing was either in the late 90s or around 2004, and my memory just doesn't remember, but there was an article about a company that had there was some manufacturing machine out on the floor, and there was a cog and gear system involved in it, and one of the main drive gears for this thing broke. And the problem was the company didn't have any spare parts available, and this machine was part of their production, pipeline. So having this machine down was literally costing them money that was quantifiable on a per time basis. But on the design side of the house, they had a 3D printer in-house, and this is an early one, probably costing $50,000 from one of the big professional manufacturers like Stratasys or something. And a design engineer sat down, took the broken gear, took measurements, and then 3D printed one out of ABS. Was it going to last for a full production run over a year? No. Was it able to get the machine back up and running for the 2 weeks that it took for the manufacturer to, send them the correct replacement part? Yes.
Wow, that's pretty awesome.
Yeah, but, again, if looking at it from a materials perspective, ABS is pretty sturdy and one of the more sturdy materials we have. PLA is a very brittle material. PLA, can break very easily, and it tends to, if you put force against it, and this goes back to understanding how you orient your print on a build for strength. It tends to separate. When we talk about those layer lines, it can very easily separate at those layer lines, whereas the temperatures and the conditions that you optimally print ABS actually give time for those plastics to fuse better together, therefore being stronger.
Okay, so you mentioned that material in particular. Are there other materials that are used in consumer quality 3D printers? Oh
yeah, there's a ton of them. ABS being very common, but fairly difficult to print. And when I say that, it's a combination of having to have a build plate that can get warm enough, and you're talking over 70 degrees Celsius. But really, the big problem is that's fine because those lower layers will stay warm. But as you print up, you start losing heat in the plastic, and as ABS cools, it shrinks. And so there are challenges where, getting your print to stay on the bed of the printer and not have the corners curl up or not having an upper layer curl and it pull that, still soft plastic at the base up. There are ways around that and a lot of techniques which are far beyond the scope of this show. In fact, we should probably have Chris from Rocket City 3D on, because I'm sure, these are the things that he does this professionally. So I'm sure he has techniques for dealing with that. PLA, on the other hand, is fairly easy. You can use blue painter's tape, which is what I use on my printer now. I go, when I run out, I go to Home Depot, I get a roll of 3M, just standard blue painter's tape, and I wipe it down with some lab grade isopropyl alcohol. Takes that wax coating on, and PLA will stick to it so good that it's actually kind of hard to get the tape off the print when you're done. Those are the two most common, but now, over the last several years, there are a lot of companies who have come up with more exotic materials. Like you can now print nylon. You can print something called PLA PHA, which is basically PLA, but it has been doped with some other chemical to add extra rigidity. There are a bunch of exotic flexible materials that have a rubber quality to them that you can print. Like bands and things that can expand and contract. There are companies starting to bring materials to the market that are designed for 3D printing. ABS and PLA were designed for other uses. PLA, if I remember correctly, if for any listeners we have in Seattle, you guys will be very familiar with the spud forks. So all disposable cutlery used in fast food and quick service restaurants must be biodegradable. Well, those are made out of PLA. Somebody just extruded it into a filament and made it available for 3D printing. But now there are companies working on trying to build materials that will have the right melting points and the right glass points where they harden, but that are easy to work with, without having to build exotic printers that, can dump an insane amount of heat in and whatnot. And then also from an artistic perspective, there are several doped filaments where you'll have a PLA, and inside of it there may be wood fiber, or there may be metal content, or there may be carbon fiber. And these materials are designed to print beautiful prints. So, for instance, there is a copper fiber or filament that I've seen that is doped with copper particles. And when the print comes out, it looks kind of ugly, but you can actually polish that print, and it kind of gets a copper sheen to it.
Is it conductive?
There are conductive filaments. The copper filament is not, because it's only about 40% copper, but there are some filaments that are available that actually are conductive.
So I wonder if that would be good enough to at least make some sort of shielding. So, if you're going to do your project box and you want it shielded, even though the outside's plastic, you could 3D print a different material on the inside, I guess, and create a shield.
So that's a really interesting idea. That's one of the things that you probably wouldn't do, simply because that type of filament is so expensive versus going and getting a piece of Reynolds wrap.
Okay, fair enough. Oh, by the way, I've also seen reference to printers that have two different material fields. Yeah. So
dual extruders, and you actually kind of just touched on this. So that's a dual extruding printer where you can load two different materials or two different colors of the same materials, and it's designed to give you more flexibility when you print. Generally speaking, most of the printers that are out there are going to be able to handle a single material at a time. There are several printers available where there are actually two physical extruders, which include the drive gear to actually move the filament through what is called the hot end. The hot end is actually the thing where you have heat that melts the plastic, and then the extruder forces it through the hot end out that nozzle that we talked about earlier. But generally speaking, it's used, like I said, because you may want to load, say, PLA filament for the actual model you're building. Sometimes if you're building a model where there's no direct physical connection to the build plate, you have to use something called support material, which the software will generate this for you to basically put a structure to build things on top of that won't directly touch the build plate. But there's a lot of people now that are using PVA, which is basically a solid form of Elmer's glue stick. But the cool thing about it is I can print my supports in PVA. I can print my object in another material, and the PVA supports are water soluble. So that's where I might want to use multiple extruders. I may also want to use multiple extruders if I'm printing something where I want the first 1/4 inch layer to be black and the next 1/4 inch layer to be white. There'll be the same materials, but I could load 2 different colors. I will say there are a lot of challenges to having dual extrusion printers work correctly because go ahead.
No, please continue.
So with a dual extruder printer, you have a lot of specific printing problems because first of all, they have to be perfectly aligned, X, Y, and Z to be perfectly parallel and perfectly parallel in every plane, which is alliteration.
And lots of alliteration.
You have to make sure that the nozzles are the exact same height in relation to the build area. You have to make sure that they are perfectly, aligned in either the X or Y axis so that when it's moving, it maintains the same relative position to the model that you're building on the plate. Additionally, with some of the way, at the end of the day, you have a filament that's getting hot, right? You're constantly dumping heat into it. And that filament will start to ooze out of the nozzle if you're not printing it. And you can't cool the print head down because it would take time for it to heat back up and it would make it take forever for your print. And so sometimes if that filament in the print head you're not using starts oozing out, it'll get caught on the side of the print and then start creating like all these really nasty like blobs and zits and whatnot.
Mm-hmm. Yeah, that's not good.
No, nobody likes blobby zits.
One other thing that I remember hearing about early on, or maybe I saw an example, was a cube that had a sphere inside, had a ball inside that was captive, and it would rattle around.
Mm-hmm.
And I looked at this thing and I thought, okay, how could you print that? And I remember something about there's, I guess, a material that could be dissolved out of the other material.
Yeah, so that could have been the PVA that I was mentioning earlier, but that one in particular, if it's a completely enclosed cube, then, how do you get water in to dissolve something, or how do you get something in to break a support material? There are many objects available for download for free that are impossible objects. In other words, there is no way to create these but for 3D printing. An example is, did you ever play Dungeons and Dragons, George?
Are you kidding? Of course.
What is the geometric shape of a D20? Is it a dodecahedron?
It's a duodecahedron.
Duodecahedron. Okay. So I have a very.
By the way, wait, hang on a second. Those of you that are listening to this, you know what we're talking about. You're our kind of people. Go ahead, Jeremy.
Yeah. So one of the people who has been incredibly foundational and a very big contributor to my 3D printing journey is a very dear friend and coworker at work, who I will only calling him out by calling him the stupid South African. And if he's listening, he'll know what that means and why it's full of love. But one of the first things that he brought into work is these little duodecahedrons that were black, and they were basically just like a wireframe. So it was just a structure. And inside there was a ball that was captive, made out of 2 colors. And the holes in the structure are not big enough for the ball to go, to pass through. Mm-hmm. And because they were printed out of a brittle material, like there's no other way to make this but for 3D printing. There's another model that has these hobbed planetary gears that would be absolutely impossible to assemble, but you make it out of 3D printing. The bonds between the gears are very weak, so the minute you turn the central hub, they all break and it spins freely.
So go back to the ball for a sec. So when they designed presumably the ball probably touched the cage.
Yes.
A pixels, I don't know what you call it.
Yes. Printing,
just
some tiny little bit. Yep. And then you would physically break it.
It just snaps off.
Probably one of the coolest objects that I have seen is a scissor lift. You print one solid device, and then when you're done, you don't even have to take a knife or break anything. You just literally start turning the crank, and it breaks all the internal, physical connections, and then you have a scissor lift on your desk that was all printed as one solid object. There was no assembly required.
Wow, that's amazing. When you said impossible objects, this would be fascinating to see. There must be YouTube videos and galore for this sort of stuff.
Oh, there absolutely are. And in fact, I will. I'm taking a note right now to make sure to add links to impossible objects.
So that gives us an idea how it works and maybe why, what I would want to use it for. And at this point, if you're thinking, okay, I want to take the plunge, is this a very expensive endeavor or is it reasonably priced these days? How much is it going to cost to get into this sort of a 3D printer for home use?
Well, to get into, you can start as cheap as $125.
Really?
Yeah.
What could you print with something like that? I mean, very small object, or is that just very crude?
So, we haven't really gotten into all the components of a 3D printer yet, but basically, you generally, as money goes up, you generally get larger build areas, you get higher quality, you get faster speed, and you get a higher range of materials. So on that low end, you're pretty much going to be able to print PLA in about a 4x4x4 cube. Monoprice makes a printer that sells usually between $125 and $175, depending on if you catch it on sale or get a coupon code. But it is technically an entry into 3D printing. I would not recommend that printer unless you're just like, oh, I'll spend, if you'll spend $30 on a Baofeng, this is like the Baofeng of 3D printers.
Okay, well put. So let's say I don't want to spend the minimum. I want to spend a reasonable amount of money, meaning I want something that's good quality. I won't feel ashamed about it because when I make the thing and I put my antenna analyzer in the box, I want it to look nice. But I don't want to go nuts, especially since this is probably a fast-moving technology. And whatever I spend money on today in 3 years will probably be kind of, old technology. So what kind of price range am I realistically looking at for a decent home printer? Well,
I'm going to say between $400 and $1,000. And one actually correction is I would actually argue that for the filament deposition printers, I would actually argue that the state of the art is actually not changing as fast as you would think. The core design of these printers, really, they've been perfected maybe, but the core technology really hasn't changed in the last 5 years.
Okay. I guess the reason I say that is the first home 3D printer I ever saw was a MakerBot, and it was a kit that you would assemble yourself, and it was functional, but kind of horsey, a little crude. And I'm sure if you go buy a commercial finished 3D printer today for the same or less money, it would be much smoother, much better. And maybe that's a 5-year difference in time.
Well,
so, you say it's kind of plateaued a bit.
Well, yeah, from the plywood original replicator to commercial manufactured, metal, nice case printers, probably about 3 years to get there. But truthfully, since then, you may see printers have gotten capable of getting faster or capable of printing, higher resolution, i.e. smaller layer heights. But especially over the last couple of years, there really hasn't been a ton going on, especially there is an open. So, man, there's so many things. There's an open source design called a RepRap, and this is kind of a reference design for 3D printers. And because it's open source, there are a billion companies that sell RepRap based printers. Mm-hmm. And the thing is about this is that the variables, like the economic levers, are going to be the quality of the stepper motors, the quality of the hot end, the quality of the drive rods, threaded rods. How big is the build plate? Does it come with a power supply? There are all of these, it's like buying a car. it'll get you from point A to point B, but you can get higher and higher quality. At the end of the day, because that's a pretty deep topic. The starting point that I recommend, and it's where I started, and to be honest with you, it's some of the best advice my wife ever gave me. When I was first looking at doing this, I had just gotten my annual YouTube check, which, I get a meager sum of money from YouTube every year for my YouTube channel. And I always take that and invest it in something that will, push my hobby or, possibly improve what I can do for my videos, et cetera, forward. And I really wanted to get a 3D printer, and I had settled on the PrinterBot brand, and that's PRINTRBOT. And the printer that I wanted from them was $600. But they offered a $400 printer. And what was cool at the time, Micro Center actually stocked these things. And my wife was like, buy the $400 option. See if this is something that you enjoy. See if this is something that you learn and pick up. See if this is something that you want to grow in. And if it is, then you go and at that point, you will know enough to be able to go and buy the printer that you really want, as opposed to spending this money now. And, maybe you like it, maybe you don't, but you could be wasting money. And I took that advice. And I went and bought what is called the PrinterBot Play. The stock PrinterBot Play, which this design is about a year and a half old. I think it was May of 2015 or so. But its stock build plate is 4 inches by 4 inches by 5 inches. That's its build area. It is capable of printing PLA, ABS, and several other exotics. Has a couple of, nice design features for the hot end. Is all open source. Like literally there are parts on the printer that when you get the printer, you print the replacement parts. You can download the files from the manufacturer. The board is basically the brains of the thing. The microcontroller board is basically an Arduino, and the firmware that runs these styles of printers is open source as well. And so what was really cool about that is that gave me an opportunity to really learn, how does changing, settings in software versus changing settings in firmware? How can I improve the quality of my print? Oh, my print is doing this, therefore I need to go adjust this setting. And it really gave me an opportunity to learn the ins and outs of it. Then there was an upgrade I was able to add for about $75. I was able to add a larger bed, which made the build area go up to 4 inches by 8 inches by 5 inches. So literally doubling the volume. And it also added a heating plate. So I was able to have a heated bed for the first time. And so at that point, I'm out $475. They're out of stock right now, but the sad thing is these PrinterBot Plays are actually on sale at PrinterBot right now for $300 without the extended bed. But like I said, that's $75. But I mean, that is absolutely where I recommend people to start with, because there's decent support. There's a good online community. Almost everything everything about the printer is open source. You can modify the firmware if you wanted to. So, you could add features, you could adjust settings. Everything runs on standard G code. It's a great way to start and really learn the ins and outs of these things. Because that's one thing that's really important. I should have started with this. A 3D printer is not a toaster.
Meaning it's a little bit more complicated than press the button.
It is. I mean, and even if you spend, $3,000 or $3,500 on like an Ultimaker, there's still a little bit of tuning you probably have to do out of the box to get the printing, to perfection. Mm-hmm. And it's important to understand that, I have to adjust things like, not only do I have to adjust the speed the stepper motor moves at, I actually have to adjust the acceleration and deceleration rates. There are, I have to understand that, as I'm getting to the end of a straight line, stop applying power to the motor and let it coast to a stop in order, things like that.
Well, now for that sort of thing, I would assume the software just handles all that for you.
Yes and no. But
that's clear.
But mostly no. I mean, once it's set, it physically does what you tell it to. But at the end of the day, you have to tell it those rates. And
but you're talking about a like a calibration step, not something that goes into.
Yes, yeah. You don't.
Okay, I'm printing a box today. I have to set the acceleration rate for this corner.
Well, actually,
as I print it.
If you are a highly skilled 3D printer, then yes, you may make adjustments based on a specific model.
Okay, but if I'm an appliance operator, I want it to work like my laser jet. I just want to say go and have it do it. So I assume these are the kind of pre-calibrations. You do them once and you're kind of good to go.
For the most part, yes. But I mean, you'll print something out. If you're not happy with the quality, you may be fidgeting with firmware settings.
Okay, so let's take a step back and walk us through the process. So
you want to talk about the components, the whole chain end to end?
Through the steps through the process. So I have an idea in mind. I want to build I need to make an L bracket for my spacecraft because without it, I'm not getting home. So what are the steps that I would go through between I need an L bracket to it's done?
So at the macro level, there are really two major pieces to the workflow. Okay. The first one is designing the widget, the L bracket that you need. The second one is taking that design file and manipulating it to do the things that need to be done to it so that the 3D printer can actually print it. So step one is design. You're going to use some type of a CAD package, computer-aided design, 3D modeling package. First shout out I will give, and this is the one that I use, but given that they are a sponsor, so Autodesk makes available for free a package called Fusion 360, that is a 3D modeling and material design package. It's actually fairly powerful, but if you are a hobbyist or tinkerer or maker and you're not using it professionally, it's free. You just have to basically I actually just got this email today telling me that my free 1-year subscription is about to end. If I am still not making money with it, go in and just check a box certifying that I am still using it as a hobbyist, which is cool.
So is that a web-based tool or is it an actual program you load on your PC?
That one's an actual program you load on your PC, although it is always connected to the cloud. All of your work is stored in the cloud. I don't think that you can export stuff, but there's no way to actually store it locally that I'm aware of. Mm-hmm. So that's one. Another one is Google makes available a tool called SketchUp. And SketchUp is another application that allows you to do 3D printing. There's a plugin available for it that both of these things can output models that are ready to be 3D printed. And that's something to point out. There is a translation layer between your CAD program, which will have its native file format, and then what the file you need is to get to the next step to prepare it for printing. And the two files that are the most common are an STL, or a stereolithography file, or an OBJ, or an object file. And this is where you literally get the simplified view of the model, pretty much just covering all of the surface detail and the surface meshes instead of all of the metadata that comes from, like in the Autodesk file, you're going to have every step of the design process so you can step through it and undo and redo and whatnot. You're not going to get any of that in the STL or the OBJ. It's literally just the model of the object. You mentioned a web browser-based application. There's another free application called Tinkercad, which is 100% in the web browser. I haven't played with it very much, but it actually looks like it has a fairly low barrier to entry to learn. I will admit, Fusion, the first time that I really had a problem, I decided I want to go learn this software. And I was able to find somebody who had a Fusion object that partially had what I needed in it. And I was able to start from their design. But it was a frustrating couple of hours to kind of learn, what does a right click do? What does, a middle click do? What happens when I'm scrolling? How do I control the camera angle as I'm, orbiting around my 3D object? Same thing with Google SketchUp. And, and both Autodesk and Google make available great videos for free on YouTube to kind of walk you through a sample design and understanding what are the tools and how do you put pieces together. But they are fairly different, radically different programs, really.
Hey, do you know that Tinkercad is also an Autodesk
product? Yes. Yeah. Yep. They also used to have, although they, as I understand it, they just discontinued this, but there was, it was like any 123D or no, it was 123D, which was a program that reminded me very similar to what SketchUp does. But I think they just discontinued support for that, which, I mean, at the time it was awesome because, it was Autodesk giving away free, pretty powerful design tools. In fact, actually the workbench that my dad and I built in my basement, I actually designed. I went in and modeled a bunch of 2x4s and 2x6s and plywood, and we actually, designed how the workbench was going to be assembled in 123D before we built it.
That's great. You had a 3D model of your workbench.
I do. Well, actually, I have a physical. I have a physical model of the 3D model of my workbench.
You could have laser printed. You could have 3D printed your workbench like one piece at a time.
Actually, I mean, if I wanted to, I actually could, 3D print a scale model of my workbench. I'm gonna have to go see if I still have that loaded on the computer. Maybe I'll do that.
Yeah, it'd be great.
But I mean, that's the design is one thing. And granted, when you first get the 3D printer, I wasn't designing stuff when I first got it. I was going to websites like Thingiverse and Umagine, and I was downloading all kinds of little trinkets and printing them.
So the first thing you do is you print someone else's thing, and maybe then do you find some of those things on the web? Like here's the ball floating around in the thing. Yeah. Do you find those not just the STL files, but also the original, let's say the
actual CAD files,
Fusion CAD files? You can actually go in there and mess with them.
Some do, some don't. In fact, I'd say it's probably more the exception than the rule that people provide it. And I don't think it's out of any animosity or anything negative. I think literally they just once they've designed the object, they designed it for a specific purpose. So for instance, Raspberry Pi cases, there are a billion Raspberry Pi case designs. Mm-hmm. Some folks who understand that their initial case design may be useful on its own. Maybe you want to adjust something, they'll make them available. But when I did my DV Mega BlueStack case, I made that file available just in case the tolerances for my print might be a little bit different than yours. But yeah, I mean, it just depends on what people want to do. But there's not, these websites for sharing like Thingiverse and Umagine allow you to attach the actual raw CAD files if you want.
Mm-hmm. Okay, so I go through the 3D CAD process, and at the end of that, and I would assume there's really nothing you have to think about targeting that design to the 3D printer, except making sure that it's not too big for your printer.
Well, the thing is the STL file is not the final thing going to your printer.
Okay, but before we convert it, are there any things that you cannot do in the design world that, or rather, you could design that you can't print? Any kind of...
Yes. Actually, there's a ton. So one thing that has been very popular is going into modern computer video games that have 3D graphics. People have been extracting the models that have been, are included in the game files and, converting them to STLs. One of the things that determines if an object is printable is whether or not the 3D model is solid. And I know that sounds silly, because if you take a model from a game, it may look completely solid, but when you go to render it down to an STL, you're going to find there are all these points where the math that describes the object literally terminates to nothing. And your printer won't successfully print what you saw on screen. So you have to make sure that that the entire object has a continuous mesh on the outside of it. So basically a continuous skin. You have to make sure that the object is manifold in the sense that it is continuous throughout. And so if you have holes in the mesh, it can really screw the print up. And the worst part is just eyeballing it. When you're designing something, it's pretty easy to tell in your source CAD software. When you're working with somebody else's model or their raw files, it may render correctly on screen, but you may not find out there's an issue until you get to print it. And when that happens, there is software. There's an application called Mesh Mixer that's available for free that actually allows you to go into an STL model and look at the mesh and try to correct, things that are wrong with it. But again, you shouldn't normally have to do that if you're designing it yourself.
Okay, so I use my CAD tool, I design my thing, and I have, when I save my CAD file, there's a native format of that data. So do I export an STL file, or what do I actually save out of my CAD file?
Yeah, you're saving your CAD file, and then yes, you are exporting an STL. In Fusion, Fusion has several different modes, one being like a 2D drafting mode, a 3D modeling mode, a material design mode, and then a 3D printing mode. And in the 3D printing mode, you can actually hook a printer directly up to Fusion 360 and it will print. I've never done that. I always export the STL for the next stage in the workflow. With SketchUp, Google SketchUp, you used to have to install a plugin to be able to export STLs or import STLs. But for all I know at this point, I just haven't played with it. This year's version of the software may have that built in. So that's something to check into. If there is no export to STL option, there definitely was a plugin available for free that would allow you to do that.
Mm-hmm. Okay, so I extract my STL file. So I'm done with my CAD tool. And now what do I do with it?
So the next step in the process is that STL or object file need to be brought into software called a slicer. And what a slicer does at its very basic function is to take an STL object and turn it into 99 times out of 100 G-code that the 3D printer will move. Now, does the phrase G-code sound familiar?
No.
So if you have a manufacturing background, that G-code is the same G-code that your CNC uses to move its tool head. It's the same technology. It's been around, I think, since the 70s. Huh. And all it is
it's basically like go to XY and do something or don't do it, or
exactly. And basically every axis in the printer. So you obviously have the XYZ axes in the printer. There is the E echo axes, which is the extruder. There's controls for controlling the temperature in the hot end of the printer or controlling the temperature of the bed. But it literally is. It's all motion code. And in fact, a slicer, there are many slicers out there. There's one that's called Slicer, which is SLIC3R. That's kind of an older one, but some printers, it's set up really well for some printers, but it's not necessarily the most easy to use. There's one called Cura, which is provided by the Ultimaker folks, which is probably one of the most popular slicers to start with. There is something called Matterhacker, or at least they're the ones who make it. There is Craftware, but there's all these different applications. And generally speaking, if you're buying a commercial printer, the manufacturer is going to tell you what you should use. So for instance, PrinterBot includes all of the profiles to understand how to talk to the printer and the configuration options of the printer with inside of Cura. And that's what they tell you to download and install. But all these different applications, they take that file and then they have algorithms on how to take, an abstract 3D object and convert it into serialized stepped instructions for a printer. There's another application that is very popular, and it's really the only one that cost money, called Simplify 3D. And Simplify 3D is very popular because it allows you to do all kinds of crazy stuff. So for instance, with Cura, if I wanted to let's say I was printing a cube, and let's say I wanted to show you the resolution changes in a print just as a demo, in Cura, I would actually have to write manual G-code or edit the final file that gets spit out to say, okay, for the first 25% of the layers, which remember, there's going to be an instruction for every vertex that gets drawn. So every single line. I could say, make the first ones 0.05 millimeters, make the next ones 0.1, then 0.2, then 0.3. In Simplify 3D, the ability to change settings like that in the middle of the print are available inside the application. And there's a million other features that make it really cool, but it is definitely the pros version of a slicer. But Cura is a great place to start. It'll give you a physical representation of your model compared to your build plate. So you tell it, hey, I have a 4x4 build area, and it will draw a box, and it won't let you load something that won't fit in the box. It'll give you tools to be able to resize your object dynamically. So if you need to make it smaller or larger, taller, you can change the dimensions of any one of the axes. You can rotate it so you can set it on the bed how you want it to be done. But basically, that's what takes your model, prepares it, and then converts it into the G-code that the printer will ultimately need to execute against.
So what you just described is, do all those programs do all that stuff, or the one that you said is you pay for? No,
Simplify 3D does it, Cura does it, Slicer does it, the Matter tool does it, Craftware does it. They all have that visual component that allow you to set where the thing's going to be on the build plate. The one thing that is complicated about this though is configure, those softwares will work with many printers, but it's understanding your printer enough that you configuring it for your printer to understand that, for instance, on a printer bot, based on the size of, I want to make sure I get this right. Based on the size of the threaded lead screws that are used to move things around, you have to have a conversion of basically steps per millimeter. How many steps in the stepper motor of the printer result in travel of 1 millimeter. That's going to be different on different printers based on the motors they use or the lead screws. And so the printer has to understand, or the slicing software has to understand things like that. Again, most of the big name brands are going to give you a recommended slicer, and it will have already taken care of that work for you.
So if you go into the slicer program, I assume that you would tell it, okay, I'm using a printer bot model 52. My print bed is so big. Are those kind of things already kind of pretty easy pull downs, or is it more you have to calibrate it and know what variables to set and all that in some configuration file?
No, because if, especially in this classification of printers, the mechanics are pretty much all the same, right? You're going to have an XYZ axis way of moving things. You are going to have an extruder of some kind, and there are a couple different kinds of extruders. You're going to have a hot end and a nozzle of some kind. You're going to have some type of a build plate that may or may not be heated. You're going to have a build area. Like, all of those variables are the same across these lines of printers as far as those dimensions all exist. It's just the value. So PrinterBot, again, when you first install it, when you go through the setup process, you literally tell it, I have a PrinterBot Play, or I have a PrinterBot Simple Metal, or I have a PrinterBot Plus. And then it will show you, hey, these are the settings that I think are correct for this printer. And then you go through and you're like, yep, that's correct. And that's your starting point.
Oh, okay, so it is pretty simple to set up.
Oh, yeah. And again, especially with the PrinterBot, once you become advanced, there are certain settings, like there's a setting called retraction. What retraction does is, as the print head is traveling from having made a print or laid down materials, it'll run the extruder in reverse and will suck that filament back up into the hot end, and that helps reduce the oozing, and can make your prints a little bit cleaner. So retraction is really important, and but the amount of retraction that you need may need to be dialed in, because, like, for instance, the setting that came default for my PrinterBot Play was not adequate enough, so I had to dial it up a little bit and just kind of step it forward, and I got into a place where it needed to be.
Okay, so odds are, out of the box, pretty easy to set up. Maybe some tuning required.
Yes, correct.
Okay, so once I have gone through the slicer step, does the slicer program do the actual printer control, or does it just translate your CAD data into the machine instructions for the printer?
So this is an it depends step. And their printers, for the most part, as far as interfacing, come in 3 varieties. Number 1 is a direct USB connection. Number 2 is a lot of printers actually have micro SD cards on their controller boards, so you can pop a micro SD card in, and the printer is either set up to print the first numeric or alphabetical file it sees, or it may actually have a little LCD interface where you can scroll through the files on the card and tell it what to print. And then probably one of the most quote unquote whiz bang features now, which is completely not necessary, but some people see it as a convenience, is a lot of these printers are starting to come with Wi-Fi, being Wi-Fi enabled with a web interface that you go to the IP address of your printer and you can upload an STL file directly there. At the end of the day, though, the thing where the printer stays tethered to the computer, that is called basically printer control function. Some slicers have printer control function built into them. Some of them rely on another application to take the STL file, the output G code from the slicer and then actually stream it to the printer. And then, some you're using 2 completely different applications altogether that don't talk to one another in a tool chain. But for the most part, the majority of the good slicers also are printer controllers. Like Cura integrates a piece of software called Pronterface, which is technically a separate piece of software, but in the workflow, it's all like you're in one application. And in that, I can do, in my workflow before I print, is I will go in there. I will hone all 3 axes, which will put them all in a default setting. I will manually turn on the heating for my hot end and my build plate. And the reason I do that is during that process, there's a tiny bit of ooze. And invariably with my printer, that ooze will kind of get stuck on the build plate and trail. So, when it gets hot before I hit print, I'm sitting there with tweezers and pulling that stuff off, whereas I wouldn't have the opportunity to do it if I just let it do it all automatically. If I have to, I can manually move the print head around in there because, again, it's full control software. But I mean, yeah, that's built into most slicers.
So the printer you have, does the slicer drive the printer, or in that case, does it generate the file? Then you have a different program that was made for that printer that drives the printer.
Yeah, so for the printer I have, which is a printer bot, uses Cura. Cura has the printer control software in it. In fact, in the view where you see the object on the print bed, where it's going to show up at the top, there's, if it detects the printer, you'll have a button for print via USB or a button for export G-code file.
Gotcha. Okay.
And my printer has an SD card reader on its control board. So if I wanted to, I could put that file in an SD card reader, plug it into the printer, and it would never have to be tethered to the computer.
So it sounds like it's really 2 big steps. Big step 1 is you use your CAD tool to design the thing and save it. And then you use your printer tool to read that file, and then it drives the printer.
Yes, that's pretty much it.
Pretty straightforward, actually.
Yes. And like I said, what's cool about this is, if you get really good, you could modify the G-code files. And again, my stupid South African friend at work, actually, he's saved prints before by being able to go in and modify G-code and tell the printer to pick back up. The print stopped mid-print. He was able to figure out where in the G-code it was, make a couple of edits to the file, and then erase all the initial instructions and have it pick up from where it failed and continue the print. And he ended up having a successful object. But he's a million times smarter than me. Have you noticed that that's my MO, is to surround myself with people that are a lot smarter than me?
Yes. Well, my MO is to find people who own boats and airplanes. So that's just never a problem. I don't need to. I think this is a good place to take a quick pause. Let's do a quick message here from one of the sponsors, and then we'll be right back. At the top of the show, I mentioned that Elecraft is our new sponsor. I want to take a minute to tell you a bit more about the company. Elecraft is a premier provider of high-performance transceivers like the K3S and the portable KX3, and their new super portable compact KX2, which is my top pick as a portable HF rig today. It runs 10 watts, 80 through 10 meters, single sideband, CW, and data modes. It's a fantastic little radio, and you'll be amazed when you see what kind of performance you can get out of something this small. And a high-capacity internal battery lets you run the radio for several hours, whether you're on the trail, camping, or taking the radio anywhere portable. You'll really enjoy using this little rig. With an excellent reputation for product quality, innovative designs, and customer service, check out Elecraft at www.elecraft.com. So, Jeremy, let's talk a little bit about once you own a 3D printer. I'm wondering, is there maintenance that you have to do to keep this thing running? The reason I ask is when I think about this extrusion head, I think, well, that seems like a maintenance nightmare, that stuff will cool and get clogged in the printer head. And what sort of ongoing maintenance do you need to do to this thing to keep it working?
Well, there's ongoing maintenance to keep the main machine running, but then there's also some stuff to do during the print. So I'll start with the machine. At the end of the day, a 3D printer is very simply a motion control device that has the ability to move a print head and or a print bed. Both of them tend to move to be able to create your objects. And from a motion perspective, you generally are riding on guide rails, you are being moved by mechanical screws, or sometimes there are rubber belts that are used to move pieces along. So lubrication, number one, really high quality silicone lubricant is good to apply every so often, and then make sure you remove stuff. Excuse me. Along with that, the belts themselves can wear out over time. And it's the type of thing that when these things need attention, they will be apparent in your prints. Like you will see things may be uneven as you're printing because there's some chatter that has occurred because there's not adequate lubrication, or if a belt has gotten stretched out, you'll find out whatever axis that controls just doesn't print as tightly as it used to. So that's for the motion side. On the actual extruder side, you can have all kinds of things happen. So if you are running cheap filament, which that's one thing to point out, is buy filament from reputable sources. A lot of these Chinese places don't really, get the core filament, which in my case is 1.75 millimeter filament. You want that filament to be perfectly round and, between 1.75, 1.8 at the most. You get much larger than that, then through the extrusion path, the actual extruder gear can grind against it and pull pieces off, and they can go everywhere and get in places you don't want them to. And on the other side of the hot end, the nozzle itself is actually considered a consumable. It's pretty good depending on how much you're printing. Over time, the filament running through these nozzles, which are generally made out of brass for the most part, will actually cause the opening to get wider. It will cause the opening at the end to get bigger, and they go out of tolerance, and you just replace them.
So is this just something you like unscrew the metal tip and screw in a new one, or is it like a little sub-assembly that you have to swap out? Completely
depends on the design of the hot end. For the most part, it is just the nozzles themselves are generally screw-out pieces, but depending on how the printer is designed, you may have to do more work to get at it. In the version of the hot end that came on my PrinterBot Play originally, you actually have to heat the hot end to temperature, so you have to actually get it to 200 C or above before you can remove the nozzle. It's really locked in there when it's cold, which stinks because for that you're using a 1/4 inch open-ended wrench, and that heat transfers really well.
Yeah, I bet.
But I mean, there are companies though out there that again, it's like anything else. There's optimizations. There's companies out there that they specialize in hot ends, and of course, there's one company in particular called E3D. Their nozzles are very easy to work on. Their designs are easy to work on, and the way that they get mounted in printers for the most part make it pretty easy to change the nozzle.
Mm-hmm. And how much is a replacement for that sort of thing? Like for your printer, for instance, if you said, "Oh man, the nozzle's messed up or clogged up, or I just want a new one," what would that cost?
About $6 to $10 for a replacement
really
brass.
Cheap.
Yeah, and generally, when I bought them in the past, like I'll buy 4 of them at a time. Going back to that E3D company that I mentioned, they have some exotic nozzles made out of either stainless or a hardened steel. And those are designed because some of those, I mentioned those like copper or brass filled filaments or the carbon fiber. Carbon fiber will eat through a brass nozzle in no time. So those more expensive exotic nozzles do tend to be more expensive and maybe up to $20 a piece.
But if you had a stainless steel nozzle, it would last you forever.
Well, especially if you're printing like PLA. But in the manufacturing process, they inherently will tell you that it's like, it's a slightly less accurate nozzle. So generally speaking, the brass is what you want to do unless you are specifically printing a very abrasive filament.
Okay, makes sense. Is there anything? Yeah.
Yeah, I was going to say now, actually, during print, some of the maintenance that you need to do is, depending on your print bed and the materials you're using to get your print to stick to the print bed, which could be everything from blue painter's tape to applying, Kapton tape, which is that kind of like orange film you see in a lot of electronics. There's also the, you may have a glass bed. I actually, believe it or not, unscented Aquanet hairspray is a very common adhesive used to help ABS prints stay down. But, you don't want to be spraying that around your printer, right? You want to have a removable bed you can take out and apply that. And there are techniques for that you should read up on. Of course, it also can be dangerous because you are, spraying in a flammable substance.
Well, that's what I was thinking.
Yeah.
Just near an open flame.
Some people will actually use like Elmer's glue sticks, the PVA material as a binding agent. So depending on what you do, there's cleanup of that. And then during the printer itself, if you get a piece of filament that is a little bit too big, it could actually get clogged in the hot end. Or if you don't clean your nozzle out using like a generic cleaning filament, or you don't take care if you're switching from one material to another. So For instance, if you switch from PLA, which prints at a temperature between, say, 185 Celsius and 210 Celsius, and you move to a plastic called PETG, which is what soda bottles are made out of, that usually runs, I think, between 240 and 260 C. If you set your hot end to that temperature, but there's still PLA in the hot end, you might actually bake it inside and then completely clog it and have to disassemble it and do a lot of work to get it cleaned out. So that's kind of the other maintenance-y thing that can happen.
So I guess it sounds like the most likely thing to need work from time to time is the nozzle which you would expect, because that's the business end of the whole thing.
Yeah, then the nozzle and the whole hot end, and then the build, the printer bed itself. Like on my printer bot, it's a machined aluminum plate, and then I apply the painter's tape. And again, for me, that's easy because number one, it's readily available, and it's relatively easy to work with. Before I print, I put a couple strips down and match the seams up as best I can. Like I said, I wipe it down with just an isopropyl alcohol that's 91% or better, or 91% pure or more. And when I'm done with my print and I get the thing off the bed, then I replace the tape. Now,
does the piece pop off the plate, or do you have to kind of chisel it off?
Also completely depends. So using the painter's tape as I have been, you kind of have to work at it sometimes because it bonds really well. And so I have a little cheap rounded corner, very flexible spatula, because you don't want to scrape at it, because if you scrape at it, you're going to leave Mars in the print bed itself, which could show up in a print. Printers with removable print beds, if your ABS print adheres really well to your glass or Lexan, you may pull it off and throw it in the freezer for an hour and let it cool off, and then it might pop off. So again, it's just a combination of what are you printing, what are you using as a binding agent, and what is the surface you're binding to determines the effort required to get it to come loose.
Gotcha. Okay. So it doesn't sound like the maintenance is really too much of a big deal.
No, it's not. But there's actually one thing I do want to make sure we talk about at least briefly, and that's safety.
Okay.
At the end of the day, one of the topics that comes up in the community from time to time is, every now and again there will be a story that says, so-and-so's 3D printer burned a house down. And at the end of the day, when you had printers that were made out of plywood, probably a lot more common. Now these things are made out of aluminum and steel for the most part, but you still have a machine that has, the hot end is capable of getting up to 250, 300, 350 degrees Celsius. And if your temperature sensor that goes to that fails and the control board isn't able to read it, you could have a condition where it just starts dumping as much current as possible into it, and it could get really hot. Same thing with the heater plate in the build plate. If a temperature sensor fails, depending on the printer you're using or the technology or the software, you could have a case where you have what's called thermal runaway, and the thing will just heat up as much current as it can accept. And that may end up being that the wires to the thing end up melting and act as a fuse, or worse. So that's safety tip number one is, especially if you go for a cheap printer, I would not let it print unattended. The other thing to consider is that one of the things we don't have a lot of data about yet is how safe it is to print these materials. There is definitely some level, especially cheap PLAs, they have this really disgusting burning plastic smell. Same thing with ABS. You don't want to be breathing that stuff. So that's something to consider too. A lot of people will keep these in a garage or a well-ventilated room that they don't occupy necessarily for the entire time it's printing, because it just, you're exposing yourself to material in the air. And for one of the few studies that I know have been done, even stuff that doesn't quote unquote smell bad, they still picked up PLA particulate in a quantity that mattered. So it's just something to consider.
Okay, well, that makes sense. You don't want to do it in your office. You probably want to do it out in the garage.
Exactly.
Okay. All right. Well, that's all pretty straightforward then. It doesn't sound like any of that's a difficult thing for the typical consumer to mess with. So let's go back to one of the questions I asked up at the beginning, which is how much does this stuff cost? Can you give us a couple of models and maybe some rough prices, and maybe tell us what's the one or two big differences between the different models?
I mean, there's two printers I'll focus on because There are some brands that, they've been around for a while. Like there's a company called FlashForge. I don't think they've really done much to innovate lately. The decent printer a couple of years ago were definitely at the top of the heap, selling for between like $800 or $1,200. But what I would consider the best entry-level printer is the PrinterBot Play for $300 to $400, for $375 to $475 with the upgraded larger and heated build plate. PrinterBot has several different models available. They're a well-established company. They were one of the first, American open source manufacturers of 3D printers, and they've been doing it a long time. In fact, they actually just released a new printer called the old one was the PrinterBot Metal Simple. This is the Metal Simple 2016 edition. And it has a lot of new features in it, like a touch screen, and I don't know if it has Wi-Fi, but it has upgraded, motion parts, and things are more enclosed overall. So that's, PrinterBot's a brand that I recommend. Another printer that I actually recommend a little bit on the higher side, and this is actually a printer that I actually just ordered over Thanksgiving with my Google check from this year, is there is a gentleman from the Czech Republic named Josef Prusa. And he is basically one of the fathers of the open source RepRap movement. And there are a million Chinese companies that have cloned his design and manufacture. Like a common one is a company called Wanhao, with it's decent stuff, I guess. But he actually manufactures and sells his version of his printer called the Prusa i3 Mark II. This actually is the printer that Make Magazine called the Printer of the Year for 2017 because it prints at a much higher quality than it has any reason to or any right to at it, for its price point, which is $900 assembled plus about $100 shipping to the U.S. But it's also available as a kit for $700 that you can build yourself. And the instructions are really good, and the printer has a lot of unique technology in it to, even if you don't assemble the thing perfectly square, like it'll still do good prints because of some of the sensing, there's a sensor on the print head so that the print head knows how far away it is from the build plate. And there's a grid of indicators on the build plate it senses to detect what a square is. And it can do, G-code coming in, and it can do real-time calculations to modify the physical movements to make sure things stay square, even if your assembly isn't quite square. But it has a lot of really good features. Its build area is about 9.5 inches by 8 inches by 8.5 inches, which is a really good size. They use a genuine E3D V6 hot end, which is a really nice hot end. On board, very protected power supply. A build plate that is heated and has some unique technology to make sure that it can be evenly heated across the entire area, plus all this self-leveling capability. It's quite a good printer. But you can all go up into the 2,000-3,000. The two brands in the higher end that I recommend are one company is called Lulzbot, Lulzbot. And they have the Taz line of printers, which the Taz 5 was Printer of the Year last year. And then there's also Ultimaker, which is in the $2,500 to $3,500 range. And these printers have larger build areas and just a lot more higher quality printing out of the box.
So for the average kind of home consumer hobbyist thing, probably something you certainly wouldn't start there. Like you said, you'd start at the $300, $400 end of the spectrum.
Well, I mean, you wouldn't start there unless, you just got went from 0 to extra in one sitting, and your first radio is a K3S.
And you want to build a custom L bracket to hold your K3
yes.
in position.
Yes. Maybe you want to build shelves because you bought 4 of them. Or maybe you bought one for every band.
You want to 3D print the new feet for the radio.
Yes.
So, well, that's great. So that's a really good overview of the whole thing. What have we not covered?
This is a very deep topic, and there are a few topics we kind of glanced over. I didn't really deep dive into the structure and mechanics of how these things work. I've got a bunch of links collected that give some good guides about what are all the individual components of a 3D printer. But there's a lot of material out there. My viewpoint is just my viewpoint based on my experience. Like I said, the PrinterBot Play, it's a smaller printer, but for what you can learn from it and the cost, I think it is definitely a very amazing value. I can't really think of too awful else much.
Okay, sounds great. Well, I think that's a really good summary. So I get a sneaking suspicion there's going to be some last minute Christmas shopping happening here.
Well, it is our job to stir the economy.
We are certainly doing our part, aren't we? It's always easier with other people's money.
Yeah.
All right, that's great. Well, thanks so much for the big overview. I think it's pretty exciting space. Oh, wait, one other thing we didn't talk about. I would like to ask you though, if I really want to do 3D printing, but I don't want to go out and buy a 3D printer, either because it's expensive or I just don't know if I'll use it very much. There's services you can use, right, where you can just send off your files and they'll do it for you.
Oh, yeah. In fact, as we mentioned, Rocket City 3D is one such company that if you design an object, they would be happy to print it and charge you for their time and materials and whatnot. But there's also a community online called 3D Hubs, 3dhubs.com. And this is basically a group of people who have printers that they make available for commercial use. And you can go through and see what kind of printer they have and look at examples they've posted of their prints and find a printer to, send your job to have them bid against it. Well, and cool. And there's thousands of people on there. Like if I wanted to, I could go on there with my PrinterBot Play and, and actually do this commercially if I wanted to.
So let's talk about the cost for that. And I'm sure that the answer is, well, it depends on like 20 things. But I have a project where I want a 5-sided plastic box and it's 6 inches long and about 3 inches wide and about 2 inches tall. And it's got some cutouts on the sides. So it's not just a perfectly flat 5 sides. And if I just want to print that out of the basic plastic material you're talking about, do you have any rough idea what that would cost me?
I don't really, only because there are so many variables that go into the pricing. And then it just, depending on how much somebody has invested to be set up to do this professionally or what machines they're running, it really, the long and short of it is you could probably get something done for, depending on the size, maybe, if it's a perfect file and it prints fine, maybe $20 to $50. It really, really, really depends.
Yeah, I'm just thinking if you have no big, strange problems with it, it's not complicated.
Yeah, it's going to be,
you got all the bugs worked out.
It's going to be tens of dollars.
Okay, so it's not like $300 and you can get a box. It's probably at the in the range that you'd be willing to pay for it.
Yeah, as a service, yes, yeah.
Okay.
And again, there are some companies that will sit down and listen to you and actually start with your design, like they'll design your models for you.
It's very analogous to, it's almost any kind of design project. Like when we do these circuit boards, you can do anything from lay out the board or design the board yourself, ship the files to a low-cost producer. They make the board and send it to you, but they don't do anything. Other companies will charge you a lot more money, but they're going to look at your design, and if anything looks strange, they're going to come back to you and say, hey, you got 2 traces running over each other. Did you really want to do that? And, of course, you're going to spend more money with them because you're using their engineering time, all the way to here's my circuit, lay it out for me. So I'm sure there's an analogous service range of options in printing as well.
Yes, exactly.
But we're cheap, and, we're going to try to make a box for $10, not $1,000. So it sounds like you can get something, in the ballpark anyway.
Yes, you can.
Yeah, reasonable. Okay, maybe we can get the Rocket City guy on the podcast. I'd love to hear him talk about it.
Yep, I've actually I talked to Chris and I told him we will have him back for a deeper dive on 3D printing.
All right, that sounds great. Well, thank you for being our expert tonight.
Well, it was about time. It's only been 12 episodes prior to this, so I figure the least I could do is offer insight and knowledge on at least one topic.
Oh, you undersell yourself. So hope everybody enjoyed this topic. It was really interesting to me, and I learned a bunch. Thanks.
My pleasure. Well, folks, thanks for joining us again for another episode of the Ham Radio 360 Workbench. Please don't forget to send us your questions, your ideas, project ideas. If there's anything about 3D printing you want to know, feel free to reach out as well. And, Google and YouTube are your friend. Don't forget that you can save 10% on your next order from MCM Electronics with code RAD10. And in the meantime, if you want to get a hold of me, you can find me on Twitter at KF7IJZ, or you can email me me, Jeremy at hamradio360.com.
And I'm George at hamradio360.com or on Twitter at KJ6VU.
And we also hang around the Facebook group, the Ham Radio 360 Facebook group. So stay tuned for our next episode and more information about board availability. In the meantime, thank you very much.
Have a wonderful holiday, and we'll see you guys after Christmas.
Merry Christmas.
Merry Christmas.
Wait.
What?
We have one more board to give away.
Oh, is this sort of an Easter egg for people willing to listen to the end of the show?
I mean, we've been doing it the last two, but I mean, we know that some of you folks have already figured this out, and I bet you actually probably will just skip to this point in the episode.
Well, why don't we surprise them and not give anything away?
No, we already told them we would give one more away. So,
all right,
we've done two. I'm not going to repeat those codes, but if you want to be entered for our third and final chance at winning an Antenna Analyzer board, send an email to workbench at hamradio360.com. And in the subject, put ho, 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 like Santa Claus.
Merry Christmas, 73s.
73. I think your dog is in the same position mine is in.
Excuse me?
I heard your dog whining.
Oh, he did. I had to kick him out of the office.
Yeah. All right,
okay.
So folks, that's...
Thanks.
I got that on tape.
Thank you.